In our day-to-day routine, we engage in activities that require measurement skills and equipment. Especially as students, we may be facing scenarios that will make us use measuring instruments such as creating a Cartesian plane or drawing schematic diagrams for our projects. Maybe even taking the mass of a notebook in order to know how many we can carry in our bag. Or let's say our teacher asked us to identify the radius of a certain object. We may easily finish these types of tasks using a simple ruler, a weighing scale, or a compass. However, as we go further in life and discover the importance and complexity of measurement, we will also need to understand how special tools for measuring minute objects and dimensions work. With this in mind, we will be discussing about one of the fundamental measuring instruments used in a lot of industries nowadays, the vernier caliper. In this video, we will discuss what it is, its importance, and how to properly use it. A vernier caliper is a tool used to measure very small dimensions of objects such as length, diameter, and depth. It is simple to use and easy for measurement. Unlike rulers that are more common among students, a vernier caliper provides greater precision and accuracy. This means that the measurements taken with this instrument is generally closer, if not exact, to the true value of the distance being observed. This is achieved through the precision scales integrated in its vernier scale. A little bit of history about the vernier caliper. The first caliper found was located within the Greek Giglio wreck, a shipwreck of the Italian coast which was dated around the 6th century. However, Greeks and Romans weren't the first to use calipers. The earliest ones were seen in China during the Han Dynasty, around 202 BC up to 220 AD. Early calipers were not only used for precise measurements of objects, but also were used by Europeans to calculate direction. In 1631, a French mathematician and scientist named Pierre Vernier published a paper which contains a graduated caliper with greater accuracy than known prior. This was later renamed the vernier scale in the 19th century and still remains in place today. To correctly read a measurement from a vernier caliper, we must first understand the functions of its parts. The first one is the main scale. The main scale runs along the beam of the caliper. On a metric vernier caliper, the main scale is graduated in centimeters and millimeters. On an imperial vernier caliper, the main scale is graduated in inches, with each inch divided into increments of 1/10 of an inch, or 0.1 inch. This scale displays the integer value of the measurement, meaning a whole number followed by 1/10 of a decimal. Then we have the vernier scale. This adds an extra degree of accuracy to measurements. It has divisions that divide the smallest increment on the main scale into decimals. Next are the external measuring jaws. These are a pair of jaws with only one side capable of movement. These are used to take measurements of outside diameters, thickness, and other external dimensions. It has a counterpart used for measuring internal dimensions, known as the internal measuring jaws. It is primarily used for taking distances between parallel inner surfaces, slots, and other inside dimensions. Another measuring part of the caliper is the depth rod. This rod is integrated with the movable jaw, which is used for measuring the depth of holes where the caliper's jaws will not fit. To precisely adjust the measuring faces of a caliper, it has a thumb screw attached to the vernier scale. And lastly, in order to hold the measurements in place for better reading or transferring the dimension to another workpiece, it comes with a lock screw which secures the moving jaw in place. Now that we are familiar with its various parts and their functions, we will proceed to the proper reading of a measurement taken with a vernier caliper. The first thing to do when using a vernier caliper is to wipe it with a soft cloth to prevent the surface from being scratched, and to maintain precise measurement by removing the dirt from the jaws of the caliper. Then, verify if its zeros are appropriately aligned. Find the zero position first by putting the two outer measuring surfaces of the vernier caliper close to each other and aligning the zero scale line of the ruler with that of the vernier scale. Assess what type of measuring method will properly give you the dimension you need. Is it an inside dimension, outside dimension, or a depth measurement? In this example, we will be measuring the inside diameter of a density cup, which is used in a laboratory. Place the inside measuring jaws of the caliper to the feature of the object that you need to measure. Make sure not to put too much force on the thumb screw to prevent scratching the object and the caliper. Securing the lock screw is an optional step in taking a measurement, but to provide a clearer reading, we will be locking the jaws in place. Read the scale value of the main ruler first. As you can see, the zero line of the vernier scale is located between the second line and the third line from the 4 cm mark. The smaller lines indicate 1/10 of a centimeter. Hence, the reading on the main scale is 4.2 centimeters. Subsequently, locate the overlapping or aligned graduations of the secondary ruler and the main ruler. A straight line formed by the vernier and main scale will indicate the reading on the vernier scale. Here, we can see that the marking between 1 and 2 on the vernier scale aligns with the graduation of the main scale. The numbers visible in this scale are read as 0.1, 0.2, 0.3, and so on millimeters. If we convert it to centimeters, it will be 0.01, 0.02, 0.03, and so on centimeters. With this, we will obtain a 0.01 centimeter reading. The shorter markings or lines in between the numbers indicates a 0.005 centimeter or 0.05 millimeter increment. This means that we need to add 0.005 centimeters to our reading. Therefore, the vernier scale will be read as 0.015 centimeters. And lastly, add the values obtained from the main and the vernier scales to get the measurement result. So, from the formula, main scale reading plus vernier scale reading is equal to the measurement 4.2 centimeters plus 0.015 will be equal to 4.215 centimeters. In this next part, we will evaluate and sharpen our skills in reading a measurement from a vernier caliper. Make sure to keep your eyes open to get the correct value from our vernier scale simulator. You may pause the video if you think you need more time in reading the vernier caliper. So, did you get the values correctly? That's all for today, guys. Thank you for listening and see you next time.